welcome to the Mole Lab. So I'm just going to be here to collect your data and then you'll answer questions. If you don't have your lab sheet either open digitally or have a copy of it printed out, get that first before we begin. All right, so we've been talking about moles. We've been talking that it's a big number. Avogadro's number, 6.02 times 10 to the 23rd. And we use it with atoms, particles, molecules because they're so tiny. And we don't want to count that many. Well, this is kind of how we use that molar mass and figure out how many moles of something we have to make it more easier to compare things. So we're going to do a couple of things. The first thing is procedure A, and make sure if you don't have the printout that you've set up at least your notebook. I'm ready to go. And we're going to start with procedure 1, burning a candle. And so we're going to go ahead, weigh that candle, we're going to burn it, and then we're going to weigh it again. And then you'll go ahead and answer the questions below. All right, so actually I forgot the information at the first part. So it says a mole of a substance contains how many particles? I just told you 6.02 times 10 to the 23rd, Avogadro's number. A mole of lead would be heavier or lighter than a mole of oxygen. If we look at the atomic mass, and that's how we get molar mass, that is how many grams 1 mole of that substance has. So if you look at lead and oxygen, those two, you can see oxygen is much less than lead. That means if I had a mole of lead and a mole of oxygen, lead would weigh and have a heavier mass since it's more grams. Okay, and the last part, it says the mass of a mole of substance can be found using the atomic mass of the substance. So that's what the periodic table is. So you can actually look on there, everything is in 1 mole, and so you can see our heavier atoms are at the bottom. And of course that's because they have more protons and more neutrons, which makes up our atomic mass. Okay, and the units of molar mass are grams per mole, which is what atomic mass is in. That's, you know, so many say oxygen is about 16 grams per 1 mole. Okay, all right, so let's go ahead and get started with our candle. And I'm going to go ahead and turn your camera down here so you guys can see the scale. All right, so here's our scale. Oops, it's a little bit, there we go. It's a little bright. Hopefully you can see it. Okay, kind of move that up a little bit. There we go. So the first thing we're going to do is we're going to weigh the mass of our candle. It's just candle hasn't been lit before. So let's go ahead and weigh that. So in your mass before, so we're in this one here, you're going to put 78.1 grams, okay? And then what I'm going to do is I'm going to go ahead and let this, I'm going to have a timer here. We're going to let this go for 5 minutes. We're going to let it burn for 5 minutes. I'm not going to have you guys sit here and wait, but we're going to burn it for 5 minutes, and then we will weigh it again, okay? So we're going to go ahead and put our candle here, and I have to get my timer, okay? And we'll make time lapse here for you guys, but not for me. I'm going to go ahead and put my timer on. Oops, if I can go to the right way. So here's my timer. We're going to go for 5 minutes. I know you guys can't see it, but we're going to light it, and then I will start it. Let that burn down to the actual candle. And we'll go ahead and start, and I'll see you back here in my time of 5 minutes. All right, welcome back. So now we've done it for 5 minutes. I'm going to blow it out, and we're going to see how the mass has changed, or if it has. Okay, and I'm going to go ahead and just pour that wax just so I don't burn myself. All right, and we're going to weigh it again, and now our weight is 77.7. So now calculate the changes in mass by subtracting those, and then go ahead and answer your questions A through F. Okay. Next thing we're going to do is we are going to do how much is in your name. We're going to do a crayon, and it's going to be my name and chalk. So the first thing we're going to do is we're going to do the crayon, and you should be now here on procedure 2. And we're filling out this data table to answer these questions. All right, for the crayon, we're going to go ahead and weigh it before. It is 5.2 grams. I have my paper here, I'm going to go ahead and I'm going to write my name in my wonderful handwriting, and I'm going to write my full name. Woo, with a little bit. And then I'm going to weigh it again. And it is now 5.2 grams. Okay. And so now you're going to answer A, B, and C for the crayon. Okay. All right. The next one we're going to do is chalk. Okay. I'm going to use these two pieces. We're going to weigh that first. And the mass before is 3.8 grams. I'm actually going to go outside for just a second. It'll be a quick in and out for you. And then I'll be right back. I'm going to write my name and maybe a nice message while I'm out there. All right. And we're going to weigh it again. It's now 3.6 grams for before. And now you can answer D, E, F, and G. All right. Now we're on the data collection for part 3. And we're going to do aspirin, wood, and aluminum foil. So we're on procedure part 3 now. And here is our data table we're going to collect. And so I'm going to do aspirin, wood, and aluminum. You will calculate molar mass and number of moles. So the mass of our aspirin is 0.4 grams. The mass of our wood is 18.7 grams. And the mass of our aluminum is 3.3 grams. For the molar mass, you're going to look up, of course, the atomic mass for each of those. And you do have on your sheet the molecular formulas to figure out the molar mass of everything there. And then you're going to calculate, turn those grams into how many moles. And then you will answer your last question, number 1. All right, so that is the data collection for our lab. Thank you very much. If you have any questions, let me know. Bye.